Hello students, I am Grishma Dalal from Faculty of Pharmacy, Dr. Subhash Technical Campus. In pharmaceutical engineering, we are going to study about size reduction, and these are some of the factors that affect the size reduction. So factors affecting size reduction. First one is hardness. It is easier to break soft material than hard material. Example, for iodine, hammer mill is used. So, do you agree on this? Always it is easier to break soft material than breaking hard material. Second is fibrous. Now, when you take any fibrous material, these are tough in nature. A soft, tough material has more difficulty than a hard and brittle substance. Remember this point. This will be helpful in practical purpose. Example, Rafflesia, ginger. Here cutters can be used. You can use easily cutter mills or any type of cutters. The next factor is friable. These tend to fracture along well-defined planes. Brittle substances can be easily converted into fine particles. Example, sucrose. Mechanism used is attrition, impact and pressure. So sometimes friable substances, they tend to easily break down, right? Just like sucrose. Here you can take attrition, impact, pressure. You can apply pressure and then crush them easily, right? Next is elastic or sticky, become soft during milling. Example, synthetic gum, waxes, resin, low melting substances should be chilled before milling. These are milled using hammer, colloid or fluid energy mill. You can use elastic or sticky material, but they become soft during the milling. So you need to be cautious about using elastic and sticky material. Here as an example it is given like synthetic gums, waxes, resins. You can perform size reduction of these things, but you have to be careful that it does not damage any milling equipment or milling part. Next is melting point. Of course, melting point is important. Why? Because some of the waxy substances they melt. Fats, oils are softened during size reduction due to heat generated. This is avoided by cooling the meal and the substance. In last video, I had told about the disadvantages of size reduction, in which it was mentioned that when heat is produced during the milling of size reduction, then it will cause damage to the ingredients or excipient. So you have to be careful. You must know the melting point of the substance that you are going to perform size reduction. Hygroscopic. Certain substances absorb moisture content rapidly. This wet mass hampers the milling process. Example, potassium carbonate. Closed systems such as porcelain ball mill is used. So, you have to be very careful while using hygroscopic materials, APIs or excipient. Why? Because hygroscopic tend to absorb moisture from the surroundings, and that is the reason they can create a burden on the milling process, and also sometimes you have to stop the milling process completely. To avoid these things, closed systems such as porcelain ball mill can be used. Next is solvated. Hydrates liberate water during milling, which causes clogging of the mill. Example, sodium sulfate. So this is also one of the most important factor that you should consider. Solvated means those ingredients, API or excipients, that liberate water during the milling process. And because of this, they will clog the mill pores. Example, sodium sulfate. Next is thermolability. Certain substances are degraded by hydrolysis and oxidation due to moisture and atmospheric oxygen. Heat produced on milling enhances this reaction. Closed system is used here with an inert atmosphere of carbon dioxide and nitrogen. Vitamins and antibiotics are milled using fluid energy and ball mills. So you have to be very careful about the thermolability of your material, which can also affect, which can undergo hydrolysis and oxidation, and that's how they cause degradation of the material. Other factors that affect the size reduction. Some other factors are like purity required. Purity is the biggest question when it comes to size reduction. Size reduction of such hard substances leads to the abrasive wear of milling part, causing contamination. Such mills are to be avoided. This point was also discussed in the last video as the disadvantage, because there are some parts which are abrasive in nature. In milling they can get mixed to your API or excipient or your drug, and that can cause contamination, so you have to avoid those type of meals. The meal should be thoroughly cleansed between different batches. The meal should be thoroughly cleansed between different batches. Flammability. Under certain conditions, fine dust such as dextrin, starch, sulfur are potential explosive mixtures. So you need to be very careful while using some of the excipients. All electrical switches should be explosive proof and mill should be well grounded. You have to be very careful. This can be considered and most important part of plant construction. Next is particle size. The feed should be of proper size and enter the equipment at uniform rate to get a fine powder. So the feed should be of proper size in order to get a fine powder. Several stages are carried out in size reduction process. Pre-treatment of fibrous material with pressure rollers and cutters facilitate further comminution. Moisture content. This is again the most important factor. In other factors, presence of more than 5% moisture influences hardness, toughness, stickiness of substance. In general, materials with moisture content below 5% are suitable for dry grinding and above 50% for wet grinding. Please remember this point. This will be helpful in your future. Thank you so much. This was all about size reduction, basic and factors affecting size reduction. Thank you.